Ever wondered how a massive machine weighing several tons manages to soar through the sky? Well, strap in, because we're about to unravel the mystery of flight. At the heart of this phenomenon are four fundamental forces: lift, weight, thrust, and drag. These are the invisible hands that guide every aircraft's journey, from the smallest drone to the largest jumbo jet. They're all integral to the process. And each plays its part in a delicate balancing act that happens every time a plane takes off, cruises, or lands. First off, let's talk about weight. This one's pretty straightforward. It's the force that pulls everything, including airplanes, towards the Earth. The weight of an airplane is countered by the force of lift, which acts upwards against gravity. Lift is generated by the movement of air around the wings of the plane. The shape of the wing, or airfoil, is designed in such a way that the air above it moves faster than the air below it, creating a pressure difference that lifts the plane upwards. Now, for the plane to move forward, we need thrust. This is the force that propels the airplane in the forward direction. It's produced by the engines, which suck in air, compress it, mix it with fuel, and then ignite it. The resulting explosion pushes the air out of the back of the engine, propelling the airplane forward. But we can't forget about drag. This is the resistance that an airplane faces when it moves through the air. There are two types of drag: parasitic and induced. Parasitic drag is the resistance caused by the shape of the plane, whereas induced drag is a result of the production of lift. These four forces are constantly at play, working together to balance each other out. For a plane to maintain steady flight, lift and thrust must equal weight and drag. When they do, that's when the magic, or rather, the physics, happens. So the next time you see an airplane in the sky, remember, it's not magic, it's physics. But how exactly does an airplane move forward? The answer lies in its engines. Let's take a closer look at these marvels of engineering, shall we? Airplane engines, specifically jet engines, are essentially large air pumps. They work on the principle of action and reaction, a concept first defined by Sir Isaac Newton. When fuel is injected and ignited in the combustion chamber, it creates a powerful blast of exhaust gases. This forceful expulsion of gas backward creates an equal and opposite force that propels the airplane forward. This is known as thrust. Now you might be wondering what happens to the fuel once it's burned. Well, it doesn't just disappear. The combustion of fuel converts chemical energy into heat energy, which then expands and accelerates the exhaust gases. The high-speed exit of these gases from the rear of the engine provides the necessary push, or thrust, to move the airplane forward. But it's not just the engines doing the heavy lifting. Propellers, or in the case of jet engines, turbines, play a crucial role too. In a jet engine, the incoming air is compressed by the fan blades at the front, heated in the combustion chamber, and then expelled out the back, creating forward thrust. These fan blades are shaped in such a way that they grab and throw the air, creating an additional push that helps the airplane move forward. It's a beautifully coordinated dance between fuel, fire, and physics. The engines consume fuel, generate heat, and expel exhaust gases with such force that they push the entire airplane forward. Meanwhile, the propellers or turbine blades add their own momentum to the mix, ensuring our airplane continues its journey through the skies. So the engines aren't just for show, they're the lifeline of the airplane, providing the thrust that propels it forward. Next time you're on a flight, remember, it's not just the wings that are keeping you airborne. It's the power of engines, the combustion of fuel, and the thrust they generate that's truly driving your journey. An airplane's wings aren't just for aesthetics, they play a crucial role in its flight. Let's dive into the fascinating world of aviation to understand the role of wings in flying an aircraft. The wings are an airplane's powerhouse, and their shape is key to achieving lift. They're designed with a flat bottom and a curved top, a design known as an airfoil. As the airplane moves forward, air flows faster over the curved top surface and slower beneath the flat bottom. This difference in speed creates a pressure difference, lower pressure on top and higher pressure beneath. And voila! The lift is generated, allowing the airplane to rise into the sky. But the magic of wings doesn't stop there. Attached to the rear of the wings are flaps, small yet powerful devices that control the airplane's speed and direction. When the pilot adjusts these flaps, they change the wing's shape and, consequently, the amount of lift it produces. Lowering the flaps increases the wing's curvature, boosting lift and reducing the speed required for takeoff and landing. On the other hand, raising the flaps decreases lift, allowing for higher speeds during flight. And what about steering? Well, that's where ailerons come in. These are hinged sections on the wing's outer edges that move in opposite directions to tilt the airplane, enabling it to turn left or right. The wings of an airplane, therefore, are a masterpiece of aerodynamic design playing a crucial role in flight. Ever wondered how pilots navigate these massive machines through the sky? Well, it's a fascinating blend of visual cues, precise instruments, and the ever-watchful eyes of air traffic control. First, let's talk about the control surfaces that steer the airplane. The rudder, located on the tail, controls the plane's yaw, moving it left or right. The ailerons, found on the wings, control roll, allowing the plane to tilt its wings up or down. Meanwhile, the elevators, also on the tail, control pitch, making the plane's nose move up or down. Now imagine you're in the cockpit. You have an array of instruments that help you navigate. The altimeter tells you your height above sea level. The attitude indicator shows if you're climbing, descending, or in level flight. The heading indicator, also known as the compass, shows your direction, but pilots don't do it all alone. They're in constant communication with air traffic control, which provides them with instructions on their flight path, especially during takeoff, cruising, and landing. This teamwork ensures safety amidst the busy skies. Moreover, pilots use visual references when they're close to the ground. They look for landmarks, roads, or other identifiable features. This visual navigation is especially critical during landing, when the pilot must align the plane with the runway. So, flying an airplane is a complex task that requires a deep understanding of both the physics of flight and the intricacies of navigation. So, how does an airplane work? We've unraveled the mystery of flight by understanding the four fundamental forces: lift, weight, thrust, and drag. We've explored the power of engines, which provide the thrust needed to move the airplane forward. We've also looked at the role of wings, designed to generate lift by changing the direction and pressure of the air. Lastly, we delved into the art of navigation, guiding these magnificent machines through the sky. The next time you board a flight, you'll know exactly what's keeping you up in the air.